Hey guys, I hope you enjoyed your spring break. I know I normally film this in the conference room on the whiteboard at my work, but the conference room has been booked all week, so I've got created a little stack of books here to balance my phone on to free up my hands, and we're going to do this the pen and paper route. So what we're doing is determining whether two vectors are orthogonal using dot products. And two vectors are orthogonal if and only if their dot product is equal to 0. So let's look at an example. So we have vector A, say 3, 5, and vector B, say 5, -3. Okay, so taking their dot product, so we have 3 times 5 plus 5 times -3, which equals 15 minus 15, which equals 0. In this case, our dot product coming back as 0 lines up with our definition of orthogonal vectors, right? Where two vectors are orthogonal if and only if their dot product is equal to 0. So we know that these vectors are orthogonal, which is basically the same as saying perpendicular. And if we draw these really quick, we can visualize it. So 3, 5, roughly, no artist, for vector A, and 5, -3 for vector B. And I hope these line up. Yeah, roughly. So in a perfect world where I was a perfect artist, we would see that these are orthogonal because the angle between them is equal to 90 degrees, and our dot product came back as 0. So we know these are orthogonal. And that's my dog's feet in the background. So that was orthogonal. Let's look at a second example to see what that gives us. So in example 2, a vector A, 3, 2, and vector B, 6, 4. Lay down, girl. So their dot product, so we have 3 times 6 plus 2 times 4, which equals 18 plus 8, which equals 26. So dot product not being equal to 0, we know that these aren't orthogonal, but if we look at them, we can see a little bit of a pattern. So the I and j values in vector B are twice the values of the I and j values in vector A. So we really have a multiplication of these lengths by 2. What that means really is that these should be parallel, and we can prove that by looking at their slope. So slope is y over x. So the slope of A is going to be 2 over 3. And then the slope of B is going to be 4 over 6, which reduces to 2 over 3. So since their slopes are the same, we know that we have parallel lines here, and we can prove it by, well, we just proved it, but now let's visualize it. So say 3, 2 for vector A, and then 6, 4. Hopefully my bias in wanting these to line up isn't influencing where I place these dots, but with vector B there, we can see certainly not orthogonal, and in fact, since we already looked at their slope, we know that these are indeed parallel lines.